Good morning to all. आवाज येतोय माझा? हॅलो, हा आवाज येतोय? Good morning to all. In last session, we complete our first chapter in Unit 2. There are 4 chapters in Unit 2. That is, first one is the helical gear. We have completed that is terminology, force analysis of the helical gear and numericals. Now we will discuss about the next topic, that is Bevel gear. What are the Bevel gear? What are the advantages, disadvantages? What are the terminology used in Bevel gear and force analysis in a Bevel gear? Okay. Is screen visible to all?
Yes, sir.
Okay. The what topic or which topic we will cover in the bevel gear, that is, first one is the terminology of the bevel gear, pitch, cone, angle and its geometrical relationship, and force analysis of the bevel gear. First of all, what is the bevel gear? Okay, if we see the image here, this type of the gear is called as the bevel gear. In this image, if we see the this bevel gear is look like a cone, means this bevel gear is look like a conical part. This is the base of the cone and this is the apex of the cone, and if we cut this cone along this line, then below this line this part is look like a bevel gear. If we see, this is the base of the bevel gear and this is the apex of the bevel gear. Okay, this type of the gear is called as the bevel gear, and the orientation of this bevel gear is towards its apex or towards the center. The thickness of the bevel gear at outer edge is more and at the inner edge it is less. Generally, bevel gear are used to transmit the power when two shafts are perpendicular to each other or when the axis of the two gears are intersecting each other. Then to transmit the power in such condition, bevel gear are used. If we see this, this is the axis of the first gear and this is the axis of the other gear. Then at one point these axes will meet to each other and such type of the gear or such type of power transmission bevel gear are used. Okay, there are generally three types of the bevel gear. That is, first one is the spur type bevel gear, means teeth are in straight line. The teeth on the gear are in straight line. Then another is the helical bevel gear, means teeth are, suppose if we consider the spur type bevel gear, then teeth are like straight line. The teeth are like this. If we consider the helical bevel gear, then teeth are like this, means these are inclined at some angle. This angle is called as the helix angle. And another one is the spiral bevel gear. In this image, if we see, the orientation of the teeth is look like a spiral. Therefore, these are the spiral bevel gear. Okay. First type is a straight bevel gear, then helical bevel gear and spiral bevel gear. Okay, these are the types of the bevel gear. Then what are the advantages of the bevel gear? The bevel gear can transmit the motion between two intersecting shafts. Means if we see the helical gear or a spur gear, both type of the gear are used to transmit the power when the axis of the shaft are parallel to each other. When we have to transmit the power when two axes are intersecting to each other, then in such condition bevel gear are used. The bevel gear are available in various forms. The bevel gears are available in as per our requirements, and they are available in various forms. While running at a high speed, there is a less noise generated. Means if we see, the noise generation in bevel gear is less as compared to spur and helical gear. Space required is less. If we compare the bevel gear with helical or spur gear, the space required for a bevel gear is less. Okay, and last one is efficiency of the bevel gear is high. These are the some advantages of the bevel gear. Okay. These are the advantages of the bevel gear. Then what are the disadvantages of the bevel gear? Disadvantages of the bevel gear is that they are difficult to manufacture. If we see the manufacturing, if we see this image, to manufacture such type of the gear, it is difficult to manufacture, and due to difficulty in manufacturing, the cost of the bevel gear is high as compared to other gear. These are the two disadvantages of the bevel gear. Then application. What are the applications of the bevel gear? The bevel gear are used in differential gearbox of the automobile. If we see at the back side of the any heavy vehicle, then there is a differential gearbox, and in such type of the differential gearbox, the bevel gear are used. These are the some applications of the bevel gear. Okay, now we will see, this is the straight bevel gear. The teeth are straight. Then spiral bevel gear, if we see the shape of the teeth is spiral shape. Now we will see the terminology used in a bevel gear. What are the terminology of the bevel gear? See here, the shape of the bevel gear is like this. Okay. This is a shape. This overall is the shape of the bevel gear. Okay. Then we will see what are the terminology used in a bevel gear. First one is a pitch cone. Pitch cone, it is an imaginary cone in a bevel gear which roll without slipping when they are peripheral contact with each other. The contact between the bevel gear is a peripheral contact, and there is one imaginary cone. in a bevel gear which roll without slipping when they are in a contact. What is the, if you see here, the triangle OAB is the pitch cone. Here the triangle OAB, triangle OAB is the pitch cone. This is called as the pitch cone. Means if we take the center of this pitch circle and draw a line, and this is the another line which will make, which is meet at the point O, and this triangle OAB is called as the pitch cone. Okay, this is the first terminology. The second terminology is the pitch angle. The angle, it is an angle tended by a pitch line of the pitch cone with the axis of the gear. Here, this is the axis of the bevel gear, and this is the line. Means this angle or this angle. Here gamma, the angle gamma is called as the pitch angle. Okay, is called as the pitch cone angle, and it is denoted by the gamma. Gamma is the angle sustained between pitch line of the pitch cone with the axis of the gear. Okay, pitch line means this dotted line. If we see this line, this is the pitch line and this is the axis of the gear, and the angle between these two lines is called as the angle between these two lines is called as the pitch cone angle, and it is denoted by the gamma. There are two angles, that is pitch cone angle of the pinion and pitch cone angle of the gear. Here only one gear is used. If we see, the large one is called as the gear, and small one is called as a pinion. And then angle, pitch cone angle, there is a pitch cone angle for a gear and pitch cone angle for a pinion. Okay, so if we represent it as gamma G, then it is a pitch cone angle of the gear, and if we represent with the help of gamma suffix P, then it is called as the pitch cone angle of the pinion. These are the terminology. Then what is the next terminology? Cone distance. It is a distance measured along a pitch line. Distance is measured along a pitch line from pitch circle diameter to the apex of the cone. From pitch circle diameter to the apex of the cone. That is distance O to A or O to B is called as the cone distance. Distance O to A or O to B is called as the pitch distance, and which is denoted by the dA. Distance from O to A or distance from O to B is called as the pitch distance. Okay, this is the another terminology. Sorry, cone distance. Then next terminology is back cone. Back cone, it is an imaginary cone and its elements are perpendicular to the element of the pitch cone. Here there is an apex of the cone, then apex of back cone. O1, here O is represented as the apex of the cone and O1 is represent the apex of back cone, and the triangle O1 to A to B. The triangle O1AB is called as the back cone angle or back cone. Okay, this is another terminology. The next terminology is back cone distance. It is a distance measured along a pitch line from the pitch circle diameter to the apex of the back cone. It is similar to that of the cone distance, but it is measured at the back side of the gear, so it is called as the back cone distance. And the distance from O1 to A or O1 to B is called as the back cone distance. Okay, it's called as the back cone distance. This is the another terminology. The next terminology is back cone angle. It is an angle sustained by a pitch line of the back cone to the axis of the gear. It is similar to that of the cone pitch cone angle. Here back cone angle is here. Back cone angle is the angle between this back cone line, this line, and axis of the gear, and this is denoted by the beta. Okay, this is called as the back cone angle. This is another terminology in the pitch cone angle is denoted by the gamma, and back cone angle is denoted by the beta. Then shaft angle. Shaft angle is denoted by the theta. Remember that there is two different terms, that is shaft angle and pressure angle. Shaft angle is denoted by the theta and pressure angle is denoted by a phi. The pressure angle is denoted by phi and shaft angle is denoted by the theta. What is shaft angle? It is an angle between two intersecting axes of the bevel gear. It is the angle between two intersecting axes of the bevel gear. Means what? It is an angle between the two axes of the bevel gear. If we see this image, in this image, this is the axis of the gear and this is the axis of the pinion. The angle between these two axes is called as the shaft angle, and generally bevel gear are used to transmit the power where shaft angle is 90 degree. Okay, where shaft angle is 90 degree. Therefore remember that for a bevel gear shaft angle are generally 90 degree, and it is equal to the sum of pitch cone angle of both the gears. Means pitch cone angle of the pinion plus pitch cone angle of the gear. This is the shaft angle. The another terminology is the face width. It is the length of the tooth measured along a pitch line of the pitch cone. Pitch line of the pitch cone. What is the face width? If we see this image, in this image, this length, this length B, here we see that is B, is called as the face width. Okay, these are the terminology. And last terminology in bevel gear is mean radius. Mean radius. Here RM is denote that mean radius, and G is denote the gear and P is denote the pinion. RM for mean radius and G for gear and P for pinion. What is mean by mean radius? It is the pitch radius of the bevel gear along a face width but at the midpoint of the tooth. Means radius measure at the midpoint of the teeth. This is the width, face width of the bevel gear, and this is the mid of the bevel gear. Then this radius is called as the mean radius. If it is if we calculate the mean radius of the gear, then it is denoted by rmg, and if we calculate the mean radius for the pinion, then it is denoted by the rmp. And what is the formula for the mean radius of the gear is, if we see here, rmg, that is mean radius of the gear, is equal to dg by 2, where dg is the diameter of the gear minus b by 2 into sine of gamma g, where b is the face width. If we see here, if we see at this portion, we have to calculate this distance, okay, and this distance is b by 2 into sine of gamma g. This distance is b by 2 sine gamma g. See once again, we have to calculate mean radius for a gear. We have to calculate this much distance. How can we calculate this? We know that this total distance is dg by 2, and if we subtract this term from dg by 2, we will get the mean radius of the gear. Therefore, remember that the formula for mean radius of the gear is dg by 2 minus b by 2 into sine of gamma g. If we write the same formula for pinion, then mean radius for a pinion is equal to dp by 2 minus b by 2 into sine of gamma p. Why here gamma p? Because gamma p is the pitch cone angle for a pinion. Pitch cone angle for a pinion, and gamma g is the pitch cone angle for a gear. Okay. These are the some terminology used in a bevel gear. If you have any doubt regarding the terminology of the bevel gear or applications of the bevel gear, or what are the advantages or disadvantages of the bevel gear, then you can ask here. तर काही डाऊट असेल रिगार्डिंग दॅट दिस टर्मिनॉलॉजी तर विचारा. नाही, okay, we will move further. Then next topic of the bevel gear is pitch cone angle and its geometrical relationship. Pitch cone angle and its geometrical relationship. If we see here, we use the term that is gear and pinion, or sometimes if you use that is bevel gear 1 and bevel gear 2. Okay. So if we see this gamma 1 is the pitch cone angle for a bevel gear 1, and gamma 2 is the pitch cone angle for a gear 2, and theta is the shaft angle, and it is a summation of gamma 1 plus gamma 2. Okay. Then R1 is the radius of the bevel gear 1, and R2 is the radius of bevel gear 2. Remember that the R1, that is radius of the bevel gear, is different than the mean radius of the bevel gear. The mean radius is less than that of the radius of the bevel gear. Okay. Now we will see what are the relationship between these two. See here this image. Let theta be the shaft angle. Theta is the shaft angle, and it is summation of gamma 1 plus gamma 2. Theta is the summation of gamma 1 plus gamma 2. Then gamma 1 is the pitch cone angle of the bevel gear 1. Gamma 1 is the pitch cone angle for a gear 1, and gamma 2 is the pitch cone angle for gear 2. T1, what is T1? T1 is the number of teeth on a bevel gear 1 and T2 is the number of teeth on a bevel gear 2. Omega 1, what is omega 1? Angular velocity of the bevel gear 1. Omega 2 is the angular velocity of the bevel gear 2. R1, R1 is the pitch circle radius of the bevel gear 1 and R2 is the pitch circle radius of the bevel gear 2. Okay. No. Okay. Then G is called as the gear ratio. Here G is the gear ratio and it is equal to T2 by T1. What is T2? T2 is the number of teeth on a bevel gear 2 and T1 is the number of teeth on a bevel gear 1. So if we see T2 upon T1 means gear 2 is has a more number of teeth, that's why we will consider that is 2 is the gear, gear 2 is a gear and gear 1 is called as a pinion. Okay, gear 1 is a pinion and gear 2 is a gear and therefore gear ratio is equal to T2 by T1 or it is equal to R2 by R1 means radius of pitch circle of the gear divided by radius of the pitch circle of the pinion and that is omega 1 upon omega 2. That is angular velocity of the pinion upon angular velocity of the gear. Okay. Now if we see here in a figure, if we see OP, this distance O to P is equal to, if we consider this, if we consider this triangle, in this triangle OP is equal to R1 upon sine of gamma 1. If we consider this triangle, then is this triangle OP is equal to R1 upon sine of gamma 1. And if we consider this upper triangle, in this triangle OP is equal to R2 upon sine of gamma 2. Okay, then if we see this equation 1, OP is equal to R1 upon sine of gamma 1 and R is equal to R2 upon sine of gamma 2. We will rewrite this equation in this way, that is sine of gamma 1 upon sine of gamma 2 is equal to R1 upon R2. If we solve this equation for a gamma 1, if we solve this equation for a sine of gamma 1, then sine of gamma 1 is equal to R1 upon R2 into sine of gamma 2. Okay, and if we see here theta is equal to, if we see this part, theta is equal to gamma 1 plus gamma 2. Theta is equal to, that is shaft angle is equal to gamma 1 plus gamma 2. So gamma 2 is equal to theta minus gamma 1. So we will put this value and we will get sine of gamma 1 is equal to R1 upon R2 into sine of theta upon gamma 1. Sine of theta minus gamma 1. And if we use, here we give the reason that gamma 2 is equal to theta minus gamma 1. And if you know that that is sine of alpha minus beta, the formula for sine of alpha minus beta, if we expand this sine of theta minus gamma 1, we will get sine of theta minus gamma 1 is equal to sine of theta into cos of gamma 1 minus cos of theta into sine of gamma 1. Therefore, sine of gamma 1 is equal to R1 upon R2. This whole term is in bracket. That is sine of theta into cos of gamma 1 minus cos of theta into sine of gamma 1. Okay. then dividing this equation by cos of gamma 1. If we divide this equation, then we will get sine of gamma 1 upon cos of gamma 1 is equal to r1 upon r2 into sine of theta minus cos of theta into sine of gamma 1 upon sine of gamma cos of gamma 1. Sine of gamma 1 upon cos of gamma 1 is equal to tan of gamma 1. Therefore, tan of gamma 1 here is equal to r1 upon r2. This sine theta is at place of sine theta, this cos theta is at cos theta, and sine of gamma 1 upon cos of gamma 1 is equal to tan of gamma 1. Okay, then if we transfer this r1 upon r2 on this side, then we will get r2 upon r1 into tan of gamma 1 is equal to sine of theta minus cos of theta into tan of gamma 1. If we simplify this equation, then we will get r2 upon r1 into tan of gamma 1. We will transfer this cos of theta into tan of gamma 1 on this side. Here they are minus. If we move this on the left hand side, then it will become plus. Therefore, this term is right at its place, and this minus cos of theta into tan of gamma 1 become a positive. Therefore, r2 upon r1 into tan of gamma 1 plus cos of theta into tan of gamma 1 is equal to sine of theta. Okay, and if we take tan of gamma 1 common from this term, then tan of gamma 1 into r2 upon r1 plus cos of theta is equal to sine of theta. Okay, here is a relation, that is tan of gamma 1 is equal to sine of theta upon r2 upon r1 plus cos of theta. Tan of gamma 1 is equal to sine of theta upon r2 upon r1 plus cos of theta, and if we replace r2 upon r1, then it will become omega 1 upon omega 2. This is the formula to calculate the pitch cone angle for a gear. Gamma 1 represent for a gear and 2 represent for a pinion. Therefore, tan of gamma 1 is equal to sine of theta upon omega 1 plus omega sine of theta upon omega 2 plus cos of theta. Or similarly, tan of gamma 2 is equal to sine of theta upon this ratio will become changed. Here for gamma 1 it is equal to omega 1 upon omega 2, and for gamma 2 it is omega 2 upon omega 1. Always remember these two difference for pitch cone angle for a gear and pitch cone angle for a pinion. Okay, these are two important formulae which is used to find out the pitch cone angle for a gear and pitch cone angle for a pinion. Okay, now generally the bevel gear are used to transmit the power between two shafts which are perpendicular to each other. Means the angle between the two gears, if we see this image, the shaft angle between the two gears is 90 degree. Here theta is 90 degree. Theta is 90 degree. If we put this theta is equal to 90 degree, we will get tan of gamma 1 is equal to sine of 90 upon omega 1 plus omega 1 upon omega 2 plus cos of theta. And sine 90 is equal to 1, cos 90 is equal to 0. Therefore, tan of gamma 1 is equal to 1 upon omega 2. And if we simplify this, tan of gamma 1 is equal to omega 2 upon omega 1, or it is equal to T1 upon T2, or it is equal to 1 by G, where G is the gear ratio. Therefore, if you want to find out the pitch cone angle for a pinion, then formula for pitch cone angle for a pinion is equal to 1 by G when the shaft angle is 90 degree. And similarly, if we want to find out the pitch cone angle for a gear, then it is equal to omega 1 upon omega 2, or it is equal to T2 by T1, or it is equal to G. These are the two most important formulae related to the bevel gear. When we have to find out the pitch cone angle for a gear or pitch cone angle for a pinion, we need to use this formulae. Only remember that when shaft angle is 90 degree, then these formulae are true. If the shaft angle is not 90 degree, then we have to calculate the pitch cone angle for a gear or pitch cone angle for a pinion by using this formula, that is tan of gamma 1 is equal to sine of theta upon omega 1 upon omega 2 plus cos of theta. Okay, these are the formulas, or these are the relation between a pitch cone angle and its geometrical relation. Okay. Uh, okay, so we will stop here. If you have any doubt related to this topic, you can ask here. जर कोणाचे काही डाऊट असतील याच्या रिलेटेड तर इथं विचारा. So I will stop meeting here. I will share the attendance link on a group. Mark your attendance. Link will open for 15 minutes.